Hey everyone, let's dive right into our last video for sequences and series. This is 15.3b. We are finding the sum of geometric sequences. Okay, as just with arithmetic, we have formulas in order to find the sum for a geometric sequence. Now, when we did arithmetic, we really only focused on using the one formula, even though the other one was at our disposal. For geometric, we are going to use both depending on the situation. Okay, so you do want to write down both of these formulas. Okay, you'll notice that one of them uses a sub 1 and the n, while the second one uses a sub 1 and a sub n. So we're really going to have to analyze the information that we're given to determine which formula we want to use. Okay, so let's take a look at figuring that out. So example number 1, find the sum of the geometric series for which a sub 1 is 5, n is 8, and r equals 5. So compared to your two formulas, okay, we're going to want to use formula number 1, okay, because we're given the a sub 1 and the n. Okay, so we set this all up. You can plug it into your calculator exactly as it appears. Be so careful of those order of operations if you are doing it step by step. Okay, and we find that the sum, okay, or the total of those first 8 terms when we add them up is 488,280. Okay, example number 2. We're given the a sub 1, the a sub n, and the common ratio. Pause your video. Which formula are we going to use? Okay, hopefully you came up with formula number 2. All right, because we're given the a sub 1 and the a sub n. So rather than having to do a two-step problem here and solve for the n, the number of terms, we're just going to use the other formula. Okay, because we don't know how many terms it is, we are just going to call this sum S sub n, and that's perfectly fine. Okay, plug it in as it shows, or just remember your order of operations. You're going to do this multiplication over here first. Okay, however you choose to do it. Your sum should be 13,120. So you really want to make sure that you can plug these into the calculator appropriately, because there's really no actual solving. There's no math to be done because you're just plugging the information into the formula and then plugging it into your calculator. So you don't want to risk getting it wrong, okay, when it's such a simple setup if you're just plugging it into the calculator. Okay, our next example. So if you remember back to arithmetic sums, when there's the plus in between, that's just telling you that you want to add these up. Okay, and the dot, 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 we don't know how many terms are in between 1 and 1/16. There could be 1 term, there could be 10 terms, there could be 25 terms. Okay, so what formula are we going to use given the information that we know? So if it makes you more comfortable, you can rewrite it like this without the plus signs. Write it out as a sequence. And we know we have an a sub 1. We have a common ratio of 1/2. And I have an a sub n. I know what the last term is. So which formula am I going to use? Hopefully you said number 2, because we don't have the n that is necessary for formula number 1. Okay, be very careful when you're evaluating this one because you do have fractions. And I would turn your final answer if it comes out as a decimal, turn it into a fraction. Okay, and that is the sum for the number of terms that they're showing us here. All right, here is your turn of the day. Your final answer is written on the bottom. Make sure that you can arrive at that before moving on. Okay, if you have any questions at this point, pause your video and be sure to ask them. Okay, and we're moving on. We got 2 more examples and a your turn ahead of us. We're working backwards. So now we're going to be given the sum and we're going to be asked to find a sub 1, which is our first term. Okay, since we are given the n, we're going to use formula number 1. We're going to plug in everything that we know here. Okay, it looks a little daunting to solve, so we're going to clean it up first. Okay, let's get rid of that -2 on the bottom by multiplying on both sides. Okay, so at this point in the problem, we actually have like terms over here. We have an a sub 1 minus 2187 a sub 1. This is the trick step, okay? We can combine those. We can do 1 minus 2187. It's the only way that we're going to be able to solve this problem. So we can't figure out what a sub 1 is if a sub 1 appears twice in the problem. Okay, so we're just combining those coefficients. Our variable, the a sub 1, stays the same, and then we can divide in order to solve. And we find out that our first term is 12. Okay, so again, these like terms, this is the trick step of the problem. So it's like having 1x minus 2187x. Okay, that's what's happening there. Let's try one more of those together. Okay, so we're given the sum, the n. Anytime you're given the n, we want to use formula number 1. And we're going to work backwards. Okay, so we're going to plug in everything that we know. And we're just going to clean up what we can here before we start to solve. So we can do 3 to the 4th, and we can do 1 minus 3. Okay, so let's get rid of that -2 first. Again, always we're going to multiply that as our first step. Okay, now remember, these are like terms. It's like a 1x minus an 81x. Gives us a -80. Oops. I don't want to divide by a sub 1. Okay, we finished solving that out. We get our first term is 18. Okay. Here is your turn for this type of problem. Your final answers are written there on the bottom. Make sure this is probably the hardest problem of this whole video. Make sure that you can do this before you move on to your next assignment. If you have any questions, you want to